Hey there class, today I wanted to work through a couple of word problem examples on how to write a system of linear equations based on a given word problem like the one we're reading in front of us. So this one, if you read through it, you can pause the video and see what all it has to offer. What I want us to focus on are two specific sentences. And so here it says the school sold 4 senior citizen tickets and 5 student tickets for a total of $102 on the first day. And then on the second day, the school took in $126, selling 7 senior citizen tickets and 5 student tickets. Now notice these two sentences are structured very similarly. It mentions one object, and I'm going to use different colors here. It mentions one object, senior citizen tickets. It mentions another object, and then it mentions a price. And the same thing here, it has price, one object, and another object. And so what we know is going on is our equations are going to have like object 1 plus object 2 in some sort of fashion, and we want to be able to find the cost of each object. So luckily it gives us, like I said, a very similar structure. So what we want to do is give each object a variable. So maybe we'll make the senior citizen tickets, we'll call those X senior, and then we'll call the Y variable the students. Now we'll take all the numbers that are given to us in a given equation, and we can turn that into, take the numbers that are given to us in a sentence and take that and turn it into an equation. So now I have 4 senior citizens plus 5 student tickets, and that's going to be equal to a total of $102, right? And then looking at the next equation, we're looking at 7 senior citizen tickets plus, again, 5 student tickets, and now it's going to be equal to $126. Now you know what's cool about this is from here we can actually solve using some of our methods we talked about yesterday. We can solve for each value and find the price of a senior citizen ticket versus the price of a student ticket using elimination, substitution, whichever you may prefer. And in the future we'll talk about how to do that with technology. Go ahead and pause if you want to take down any of these notes. Notice this question is actually on the back of the packet in the word problem section. You'll be able to copy down these notes and be able to help yourself understand how to plot the information from a word problem. What I also wanted to do in this video, I'm going to flip pages now. So I wanted to talk about a 3-variable system. If you're in pre-AP, this 3-variable system is all you're working with right now. But if you're in regular, the 3-variable system is something that's kind of new. So I wanted to introduce that using a word problem. So this video actually serves 2 purposes. Notice it works very similarly. I'm going to highlight the first sentence. We're looking at 5 tomatoes, 2 cucumbers, and 4 peppers cost $19. In the second sentence, 2 tomatoes, 2 cucumbers, and 3 peppers cost $14. And then the third sentence is 6 tomatoes, 3 cucumbers, and 4 peppers cost $23. So here, the only real difference between creating a 3-variable system is that we have more things to account for. So if we wanted to start with X being the tomatoes, which is weird making in blue the tomato, and then Y, we can do cucumber, And then I'm going to use a letter Z as my third variable, and that's going to be my pepper, which actually makes a little bit of sense for it to be green. So tomato, cucumber, and pepper, all I'm going to do is I'm going to piece all that information again. So here I'm looking at, for each one I'm going to write the same vegetable so I don't have to switch between the colors all that often. So I'm going to write 3 equations. Here's equation 1, equation 2, equation 3. So now looking at the top, I have 5 tomatoes in the first equation versus just 2 tomatoes in the second equation, and then 6 tomatoes in the third equation. So there's 5, 2, and 6. Now I'm going to go over to the cucumbers. I'm going to add 2 cucumbers for the first equation, 2 more cucumbers for the second equation, and then for the last equation we have 3 cucumbers. And then last but not least, we're going to talk about the peppers. So plus 4z for equation 1. Those peppers are gone. Plus 3z for equation 2. And those peppers are gone. And then plus 4 more z for equation 3. And all that's left is setting those equal to those prices. So the first equation is equal to 19. Second equation was equal to 14. Last equation was equal to 23. And so now pre-AP you should be able to solve this using some of the methods that we've been talking about. Grade level, we're going to come back to this type of question when we start to look at using technology. And pre-AP you'll see that too. When we use technology, we'll be able to handle these larger order questions using something called a matrix. But that's just a preview of what to look forward to. So this is how you pull the information out of a word problem and turn it into an equation. Notice it usually stays pretty well organized in sentences, so all you have to do is give each object a variable and just translate it into an equation. Thank you for watching. If you have any questions, let me know in class, and have a good one.